everybody. So I'm just walking outside here, as you can see, thinking about physics. Isn't this sky beautiful? So in my videos I've been talking about Newton's law of gravitation. I've been talking about Kepler, Faraday, the Mars rover. I'm just really excited about the Mars rover. Like, how are we able to get the Mars rover from Earth to Mars? That's a very interesting question. It basically goes back to, let's talk about the history of science a little bit. So in Europe, I guess starting with the Greeks thought that the Earth was the center of the universe, and that's natural because then it just feels like we are and we're not moving, and that the sun revolved around the Earth. Then Copernicus comes along and turns that theory on its head and says, no, the sun is at the center of the universe and the Earth revolves around the sun. And Galileo agreed with him, Kepler agreed with him. So Kepler was observing Mars's path in the heavens, and he basically was able to sort of model Mars's orbit as an ellipse. An ellipse is a squash circle. Like, if you can see these cars, like the Toyota emblem. The Toyota emblem is in an ellipse. An egg, an oval shape is like an ellipse. A football is like an ellipse. Ellipses can have various degrees of squashiness, and the technical term for squashiness is eccentricity. The more so-called eccentric an ellipse is, the more it starts looking like a hot dog rather than a circle. Well, Mars's orbit is not very eccentric, it's almost a circle, but Kepler was so careful in his analysis of Mars's movement in the heavens that he was able to determine it was actually an ellipse, not a circle. But he didn't really explain why it was an ellipse. It took Isaac Newton to do that. Yeah, let's look at some ellipses. So the Kia logo is an ellipse. I don't know if you can see these logos. The Toyota logo, the Ford logo is an ellipse. Ellipses are everywhere. The Mercedes logo is a circle, though. Saturn, that's an ellipse. Volkswagen is in a circle. Toyota an ellipse. What's this? Nissan is a circle. Toyota ellipse. Toyota ellipse. Toyota ellipse. Ford, Chevron. Okay. Volkswagen ellipse. Mercedes circle. Volkswagen circle. Anyway, Earth is almost a circular orbit. None of the planets really have perfect circular orbits, though. Earth is pretty close to a circle, but it's not a circle. It's an ellipse. It's squished. In fact, when it's winter for us in the northern hemisphere, we're actually... Let's see, how does this work? Good, how are you? When it's winter for us in the northern hemisphere, we're actually closer to the sun than we are in the summer. It's because of our elliptical orbit. It's not a perfect circle. We're actually closer to the sun in the winter. So why is it so cold in the winter? It's because the Earth is tilted on its axis, so we're facing like a sort of away from the sun. Whereas in the southern hemisphere, it's the opposite. So in the southern hemisphere, in the summer, they're closer to the sun, and so the seasons are like exaggerated, I guess you might say, at least summer. So that's, I think, one reason why in Australia it's super hot in the summer. Like, I think the streets like melt because they're actually closer to the sun in the summer. So yeah, basically understanding ellipses helps scientists send rovers to Mars. Okay, that's all for now, folks. See you in the video. Bye.